In this series of lessons, we'll talk about animation. After completing the previous part, you should have a file with a similar rig. Actually, you can skip the rigging step and use the ready-made rig from the materials that come with these lessons. Before you start, make sure that there is no animation on the rig controllers. If there is one, it can be removed by first selecting all controllers, or via anim picker, or by using Select Members command from the right-click menu on Selection Set by selecting these controllers, and then apply the Delete Keys command from Keys Options. You can see that the channels in the Channels box of the controllers are now turned gray. This indicates that they don't have any animation. If you made a special skinning animation, you can save the version without animation to a separate file. I'll save the rig for the character as a file dickrig01. While working on the animation, there are often situations when you need to make some changes either in the model or in the rig. If some scenes with this character were already animated, it'll be very difficult to make each change in all scenes manually. You'll need to copy the updated rig to each scene, replace the animations from the old version of the rig to the new one, and so on. If you want to optimize this process, there are references that allow you to import some file into a scene, including a character rig, so that the connection with this file is preserved and all changes in the initial file will be automatically updated in all scenes where the file is used. This approach can be considered as a standard for creating animations, so I recommend using it. I'll create a new scene, or it's possible to run another version of Maya and load the model with the rig as a reference. We apply the Create Reference command from the File menu. I'll set all the default settings and specify the rig file. In Viewport, we see our well-known rig, and in Outliner, we see its objects with a specific blue icon, indicating that they are loaded as a reference. At the same time, the so-called namespace was added to the object names. This allows you to load multiple copies of the same file in the same scene and still avoid problems with identical names. There is a reference editor to manage the references. So I open it. It shows the previously created reference. You can see the files to which it is referencing and also the namespace. You can change the namespace. For example, for compactness, I'll just call it Dick. And you can see in Outliner that the names of the objects have changed. You can also specify a different file. That is, you can have multiple versions of the rig and switch between them. You can upload the reference by clicking on this checkbox and the animation on the rig will be saved and appear on the next load. This can be useful if you want to simplify the scene for speed purposes. If you have several characters in it, or for example a complex environment, references don't allow you to change the hierarchy and most other things. So all changes to the rig and to the model must be made in the original rig file. In the animated scene, you make only animation. An important point: keep in mind that when you update the reference in the animation scene, Maya connects the created animation to the rig using object names and paths to their operational attributes. As a result, if you have renamed or deleted any components, or for example moved some attributes to another host, when you update the reference, Maya won't be able to automatically connect the animation you created earlier. In this case, you will have to move the animation manually. You can import a reference, which means break the connection to an external file, using the import objects from reference command or through the reference editor, or via menu by right-clicking in the outliner. This may be useful for painting the skin weights, but I'll tell you about it a bit later. Pay attention that this operation can't be cancelled. Therefore, I'll create a new scene. I'm importing the reference again, and I'll show you the functionality of the rig to make it clearer for you how to work with it. As you might have noticed earlier, mGear has a convenient context menu that is available by a right-click, which will work if the corresponding option in the mGear menu is enabled. It works for dedicated controllers, and most of the commands here are rather obvious. Select Host specifies the host of a component, that is, the object that contains its animation attributes. Select Child Control selects all child controllers. Reset clears the transformations of the selected controllers. Mirror copies the controller's pose to the opposite side. Flip mirrors the pose. And you can also select all controllers and keyframe all child controllers. So if you select the parent controller of the global networks and apply this command, it'll load on all controllers of the rig. Since this menu is contextual, some controllers may have parameters related to this component. For example, the context menu for some components allows you to change the parent, switch between direct and inverse kinematics, and so on. In general, it's a pretty useful tool. I recommend you use it. Now let's look in detail at the components and their attributes. The common global and local controllers are very simple. They shift the whole rig. Two controllers allow you to have two layers of transformation. Sometimes this can be helpful. The whole body can be transformed by this Body CTL controller. The component I used for the spine works in two modes simultaneously. In direct and reverse kinematics mode. The direct kinematics, or FK controllers, these red squares, behave like a normal hierarchy from pelvis to chest. As the pelvis rotates, the chest inherits its transformation. I rarely use these controllers. I find it much more practical to use also inverse kinematics for the back, and that is why I made them smaller. The inverse kinematics mode, or IK, allows you to set your posture primarily with the pelvis and chest controllers, which are independent of each other. At the same time, they work over the pose set by the FK controllers as an additional layer of transformation. You can see that the spine can stretch and squash, and the degree of stretching and squashing is controlled by the max stretch and max squash parameters. They are located on the common back controller, in a Body CTL object, as well as the other attributes of the spine component. You can see that if you increase the max stretch parameter, the spine will be able to stretch harder. The volume attribute controls the effect of volume preservation during stretching and squashing. If it's equal to 1, the spine will become thinner during stretching, and thicker during squashing. Decreasing this parameter reduces the effect. Now the spine is short and the effect isn't very visible. The value of squash and stretch is set in the component's guides before building the rig. With the help of these curves, the Lock ORI 0 and Lock ORI 1 attributes lock the pelvis and chest rotation, when the pelvis and chest controller is shifted. If these attributes are equal to 1, the chest and pelvis won't rotate. If they're equal to 0, they will. There are also additional tangent controllers. These yellow spheres are designed to fine-tune the curvature of the spine. Each is the child of the corresponding chest or pelvis IK controller, and also inherits their transformations. You can see how the controllers shift the joints, but due to automatic skinning, they have little effect on the geometry. This can be fixed later, during the skinning correction phase. Tangent attributes on the host allow you to add an extra layer to move the tangents closer and farther away from the center of the parent controller. Let's move on to the limbs. By default, the leg works in inverse kinematics mode and is controlled by the foot IK controller and a semi-vector that sets the direction of the knee. You can also displace the pelvis joint and the knee. The inverse kinematics mode allows you to fix the foot so that it doesn't depend on the body. This is very important when you animate walking, running, and so on. Note this cross-shaped controller called IKCNS-CTL, which is the parent of the IK leg controller. It allows you to get another transformation layer for the foot. It can be reconstructed to some moving objects in the animation scene beyond the rig, like on some moving platform, so that you can animate the leg on top of the platform's movement. In addition, if the character is moving, for example on an inclined surface, you can use it to set the orientation of the foot so that the IK controller transformations are more clearly represented. The leg can also operate in direct kinematics mode. If you look at the attributes of the leg and on the host, we see the FK-IK blend parameter. It allows you to switch smoothly between modes. If the attribute is equal to 1, then the leg operates in IK mode. If it's equal to 0, then it operates in FK mode. Joint position blending takes place between 0 and 1, between the FK and IK controllers. In extreme values, the controllers of the opposite mode are automatically hidden. Each segment in direct kinematics mode inherits the transformations of its parent. You can rotate the controller as well as move it. As you may have noticed, if the inverse and direct kinematics modes set a different pose, the leg will shift when you switch between modes. Pay attention to the additional commands in the context menu for the leg host. Switch leg to IK or switch leg to FK, which allows you to switch modes without changing the pose. They combine the controllers of the mode on which the switch is made from the current pose and leg. And that is why the switch is made without shifting. Also, there is an option to switch to another mode and automatically create keys on controllers and attributes. Moreover, you can transfer the animation of one mode to another with the range switch command. Let's take a look at some of the leg attributes. Bear in mind that many of them work only for a certain mode. Most of them work for inverse kinematics. The roll attribute shifts the direction of the knee given by the up vector. Scale allows to scale the leg length for inverse kinematics mode. Max stretch sets the maximum length of the leg to which it can be stretched. The slide attribute shifts the knee to the pelvis joint or to the foot. Softness allows you to smooth the angle at the knee joint when the leg is straight. When the leg is almost straight, small shifts of the leg controller give a very noticeable and abrupt change of knee posture, and as if a click. It's rather hard to smooth it out manually. But if you increase the softness a little bit, you can remove the jumps automatically. The reverse attribute allows you to curve the leg in the opposite direction. Roundness allows you to round the leg. And volume, like on the back, controls the preservation of volume during stretching. If it's equal to 1, the leg will become thinner. If it's 0, it won't. Reference attributes for the foot controllers of up vector and knee, namely IKRef, UpVref, KneeRef, allow you to switch the parents of the respective controllers, which were specified in the guide properties when building the rig. By default, the IK leg controller inherits the transformation of the local controller and is body independent. If I change the IK_ref attribute to body, you'll see that the leg will inherit the body. Take note that the parent switch can also shift the controller if the pose isn't the same as neutral. This is due to the dynamic parsing mechanism. If you want to switch the parent without changing the pose, you can use the context menu, which compensates for the controller shift when you change the parent, similar to how the IK and FK mode switching commands work. Controllers relating to the foot component allow you to rotate it relative to the heel, midfoot, and toe. The roll controller allows you to do this roll from heel to toe and vice versa, as well as side-to-side tilts. The whole foot can be rotated relative to its center, and the toes can also be flexed. The hand is very similar to the foot, as their attributes are identical. I will not dwell on them in detail. You can also use the context menu of the host for IK-FK switch and parent switch. But the difference is that you can specify whose rotations the shoulder will inherit. As default, it inherits the chest. When spine CO tip is specified, you can see how the arm rotates with the chest. If we change the parent of the arm to body, for example, we see that the arm rotation is now independent of the chest. We have an additional controller on the shoulder called Shoulder Orbit CTL. I use it quite rarely, so I made it so small, but it may come in handy if you face the gimbal lock. A couple of words about this phenomenon. The point is for controlled interpolation. 3D rotations occur in turn for each axis. It's similar to a gyroscope. If you switch to gimbal rotation mode, Gizmo will show the real orientation of the axis, which correspond to the value of rotations in the channel box or in the graph editor. You may have a situation where two axes overlap and we see that I can't rotate this arm in this direction. Obviously, you can choose a different manipulation mode and rotate the controller as you want, but the rotation will affect the values for all axes at once. As a result, it would make it difficult to date the animation in the graph editor and lead to strange interpolation movements. In order to avoid this, you need to use the second layer of rotations, which gives an additional controller. Now let's move on to the fingers. These are just chains of direct kinematics, and you can rotate, move, and scale the phalanxes. There is an additional controller on the big toe, similar to the shoulder, to avoid gimbal lock. I have already shown the behavior of this meta controller before. It distributes the transformations between the fingers. The component in the neck is similar to the spine. It also works in two modes at once: inverse kinematics and direct kinematics. These red squares allow you to rotate in FK mode. They operate simultaneously, similar to the spine. Neck has similar attributes, so I will not describe them in detail. You can also change the parents through the context menu. At the moment, FK controllers have local as a parent, so it doesn't depend on the chest in any way, and the head remains in place. We see how far you can stretch the neck. And if you change the parent to spine tip, the neck will inherit the chest. And you can also change the way the FK orientation of the head controller is inherited. By default, it inherits the transformation of the neck. If you specify a common local controller, the head won't inherit the rotation of the chest. Occasionally, this comes in handy. Everything is made based on the spring chain component. Hair, ears, glasses, mouth are just FK chains with additional attributes for the spring. They have the same attributes, damping, stiffness, for each joint. Briefly speaking, damping controls the smoothness of the spring, and stiffness controls its elasticity. The exact value must be customized based on the animation, and therefore I'll return to them at the very end. Now we can come exactly to the animation. Before starting to work on the animation, you need to set the frame rate of the scene in the file settings in the time slider category. This means the number of frames per second of animation. We worked on this project at 24 FPS, so we leave the default value. It's worth to change the playback settings. Playback speed set to play every frame, and max playback speed at 24 FPS, so that Maya always plays every frame no faster than 24 frames per second. Also, in the animation section, you should set the evaluation mode to parallel, which will greatly increase the responsiveness of the rig by means of caching. You should also enable GPU override. This blue line shows the cached range. You can see here that after manipulating the controllers, Maya automatically caches all the frames. When we play the animation, it'll always be displayed in real time, which is very convenient because you don't have to do previews all the time. You can set up the caching from the playback menu. Here you can choose from 3 algorithms, depending on the capabilities of your computer. Some of them may be faster. I'll leave it on the default setting of evaluation. Furthermore, in preferences, it's worth to enable cache smooth meshes to improve speed performance with smooth geometry. Usually before you start animating, it's better to plan the work, to think about how the character is supposed to move. Maybe sketch out some specific poses on paper, find them on the internet, or record a video reference by yourself. This guy I found on YouTube, I think he has the suitable dance. I downloaded it into Blender to make it easy to analyze the movements and poses frame by frame.